Right, guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at a general example of the concept of the principle of superposition of charges. And this is going to complement on the previous discussion whereby we looked at basically what the principle of superposition of charges entail and its implication on the concept of the Coulomb's law. Now, we had mentioned that basically the Coulomb's law applies to n pair of point charges. And of course, in case we had a combination or a system of charges which constitute more than two charges, then therefore we're going to apply the principle of superposition. In this particular case, we said that when more than two charges are going to be present in a system, the force being experienced by any of these specific charges for A, B, C, and D are going to be simply a vector sum of the forces exerted by other charges which are present in that specific system. Now, we have looked at a particular example whereby we said that we can represent the various forces which are going to be experienced by these particular particles. And therefore, the example on the board which I've given, of course, is going to be another example of the application of the principle of superposition. Now, in this case, I'm going to indicate this distance between the charged particles as d. So we're going to have this one given as d as such. And then we're going to have these two charges for A and B being given a charge of a quantity Q for both. And then we shall have a positive 2Q being given for D. And then we are going to have negative 4Q being given by this specific particle for C respectively. Now, if the forces applied by the charges are placed at B on A, so the forces which are going to be applied, of course, by the charge placed at B on A. So this is going to be a force which we are going to be giving using FB. So FB is a force which is going to be applied on A by this specific particle, which is going to be P. And therefore, we are going to see that this force can be indicated using this particular arrow. Now that we can see there's a negative quantity which has been given, so we assume that the two for Q's are positively charged particles, and therefore this is going to be a repulsive force which is going to be pushing this specific particle in that direction. If we are required to find the force applied by the charges C and D on A, and therefore we have been told that the force which is going to be applied at this specific point, particularly which is going to be experienced by A due to the presence of B is given as F. So I've just given it as FB. So we can consider this one to be a quantity of the net force which is being applied at this specific point. Now, suppose we are requested to find the force being applied by C and D, or the two particles on A, then therefore we're going to use the principle of superposition in trying to find this one. So we can be able to represent the force B on A being given in this specific order using the general form of the Coulomb's law, and then this is going to be given as such. So I've basically done a substitution for this specific constant, and then we're going to have the quantities, the product of the two charges as per the Coulomb's law for Q and Q, and therefore we're going to have this one divided by the square of the distance between the two, and this is going to give us a value of F basically, which I've given above, and that is going to be the force being experienced by this specific particle of A due to the presence of B. And there's a force which is going to be experienced by A due to the presence of D, and this is going to be a force being experienced in this particular direction. So A is going to experience a force due to D, and the two particles are positively charged, and therefore we're going to experience a force which is a repulsive force being indicated in that specific direction. So this is going to be a force on A due to the presence of a D. This is going to be a force on A due to the presence of B as indicated above. So we can as well represent that one in terms of a formula, whereby the force is given in terms of K, the quantity Q times 2Q for the lower one, which is D, divided by the distance between the two, which is square of D. So this is going to be given in terms of 2K Q times Q all over d squared given as such. So if we try to look at this one, this is going to be a scalar multiple of the first force which we had given in terms of this representation, and therefore this one can be given in terms of a 2f given as such. So this is going to be this force Fd is going to be twice in terms of a quantity with this first one, and that's going to be representing the force over D on A given as such. So if we try to consider this one, then therefore we're going to assume that these are going to be perpendicular to one another. So there is a vector force which is going to be, of course, indicated using this specific diagonal, which of course is going to be a resultant of the force being applied due to C, and therefore that's going to be given in terms of Fc. Now if you try to look at this one, then therefore this force is going to be directed towards this specific particle, since the two opposite charged have opposite charges, and therefore we're going to experience the forces of attraction. So therefore we can as well quantify this as specific force, but first we're going to find this distance between D and A, and therefore this distance can be given in terms of DSC. So the first one we are given it in terms of this one, so we're going to have the distance DSC using Pythagoras theorem, and this is going to be the root of d squared plus d squared, which is basically 2 root d given as such. So basically this is going to be d root 2, so it's going to be the root of 2d squared, and therefore this is going to be a d the root of 2 given as such. So basically dA is going to be d the root of 2, and therefore we can represent the force C that is acting on A using this specific formula for Q, and then multiplied by this particular quantity for the negative 4Q. Perhaps I can give it in terms of those brackets to avoid that confusion of negative, and then we're going to have this one divided by the square over, so this is going to be d the square of 2. So basically this is going to give us a value of negative 2f. You can do an evaluation to confirm that one. So this is going to give us a value of negative 2f given as such, and this is going to be the value for the force which is going to be experienced on AD to the presence of C, on AD to the presence of D given as such, and on AD to the presence of B. And this is one of the applications of the principles of superposition, as we have been mentioning in our previous videos, and this is going to assist us in tackling any of the problems that we may come across in our subsequent discussions. So kindly check our description boxes for various links of other similar videos, and also subscribe and engage us in the comment section, and also ring that notification bell so that we can be getting updates on various uploads that we do in maths and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.